It's visible, right? Is it
Yes,
visible?
sir.
Yes,
Okay,
sir.
fine. Okay, fine. So we were discussing about these various components of NLP, uh, and we also have seen like there are various steps like stages, phonetics and phonology. Then we are having some morphology. Then about lexical analysis, about syntax analysis, about semantic analysis, about pragmatics, and about discourse. All these concepts we were discussing. All these are the stages of natural language processing that we were discussing. And also we have discussed about the concept of ambiguity, lexical ambiguity, or maybe like a syntactical ambiguity or structural ambiguity or referential ambiguities like this. And these type of ambiguities, it occurs in almost all the stages of natural language processing, where maybe like in phonetics and phonology, morphology, lexical, syntactical, semantic, or pragmatics and discourse. All these stages, the ambiguity occurs. And we have seen also like various examples in each of these stage how the ambiguity takes place. So today, what we will try to do is that we'll try to discuss about various some concepts, very basic concepts that are involved or terminologies that are involved in this natural language processing. Okay. After discussing that one, then we will enter into the concepts like the operational concepts of natural language processing. So we have stopped here at discourse analysis. We have stopped, right? So we were telling about discourse analysis, the ambiguity, how ambiguity occurs. If you have seen that, like from sentence, single sentence to the next sentence, sentence to sentence, our assumption or the meaning gets changed. What we assume, our perception gets changed, right? This is what we have seen about a discourse analysis. So we have to make like if a sentence is there and it get parsed up to discourse analysis, it means that it's fine. Now we can get the exact meaning of that particular sentence with respect to the semantic meaning, with respect to the pragmatic meaning, and with respect to the discourse meaning. Okay. Now what is basically some terminologies, as I said you, that we will see today. And what are the concepts, or what are those terminologies? If you see, first one is the tokenization. This is a very basic step uh, in natural language processing. Given any
Uh,
sentence,
Interrupt you, but we are still on the discourse analysis slide.
okay, you got it now?
No, sir, not yet. I don't know about others.
Anybody got
Yes, sir.
tokenization
We are
slide?
also. No, sir. We are at discourse analysis itself.
Now,
Yeah, sir. Now got it.
Yes, sir.
okay, fine, okay. So tokenization is the process of breaking up the text into many small pieces. So it works by separating words into spaces and punctuation. If you see here, see, let's go to New York. This is the sentence that is given. Let's go to New York. So how we tokenize, you see that first one is let's, okay, then go, then to, then New York, exclamation mark, and then closing the inverted commas there. Now again, let's can be choked as or tokenized again as this starting inverted commas, okay, opening inverted commas, and let's. Again, let's can be tokenized as let apostrophe s. So like this, if you see step by step, if you see at the end, if you see each thing is a token. Now opening like a inverted comma is a token, let is a token, apostrophe s is a token, go is a token, to is a token, New York is a token, exclamation mark is a token, and then closing the inverted comma is a token. If you see here, like individual things are there like that. And actual the sentence was let's go to New York. Okay, let's go to New York. This was the sentence, but when we tokenize, okay, how, like individual like that, like each element at the basic element, if you see down the downmost row, you can say is a token here. Okay, and like what is the use of tokens? So it break a sentence into words. You can say that it breaks a complex sentence into words, and it understands the importance of each of the word with respect to the sentence. Okay, and it produces a structural description on an input sentence. These are the basic uses of tokenization. And what are the types of tokens we are having? Bigram tokens, trigram tokens, and n-gram tokens. What is this bigram tokens? It means that we are having tokens, right? We have been dividing the sentence into individual tokens. Now, when two tokens are combined together, tokens of two consecutive written words are known as bigrams. What about trigrams? Tokens of three consecutive written words are known as trigrams. And tokens of any number of consecutive written words are known as n-grams. It means that n number of written words, they are called as n-grams. If three words combinedly together occur, okay, we call that one as trigram. If two words combinedly occur, we call them as bigram. If single word occur, we call that one as a unigram. Or like if five words occur, we call them as pentagram, right? Uh, so this is how, if n words occurs, n grams. That is what you need to know about, just simply about tokenization. And you see here an example is given. If some examples of unigram, bigram, and trigram. The sentence that is given here is, this is a sentence. Suppose this is a sentence. You see here, this
Sir,
is, yes.
sir, we are on slide bigram, trigrams, and n-grams. We are not on the example slide.
Next is coming maybe. Hmm. See, did you get it?
No, sir,
Did
it
you get the
lags
slide?
almost 1 to 2 minute lags.
2 minutes lag.
Yes, sir.
Now did you get it?
No, sir. Now, just now we get.
Okay, maybe I will close some other applications. Okay, so this is a sentence. For unigrams, you can find out that this is a sentence. So there are four tokens here, right? Four tokens. This is a sentence. And for unigrams, each of this token is divided. If it is bigrams, these four tokens are combined as such. This is, you see the blue encapsulation here. This is, okay, this and is combined together to make one bigram. Is and a combined to make one bigram, the green color one, okay, encapsulation. And a sentence is another one, the orange color one, to make as another bigram. If it is a trigram, you see here, this is a, okay, one trigram is, this is a, and another trigram is a sentence. So please remember that this is a and is a sentence. So like this, suppose if I say n gram, it means that n combination of words has to occur. Okay, And if I say bigrams, 2 combination of words, trigrams, 3 combination of words, like that, n grams, n combination of words. And if it is single word occurring like that, then we call that one as a unigram. Okay, yes, fine. The next slide got changed.
Sir, not yet.
How come this delay is occurring? I am not able to understand.
Maybe net issue.
Sir, I can share my screen so you can see in real time.
No. Still that is that delay will be there.
Sir, now it's changed.
What is visible to you on your screen now?
Yes, sir. So now it's a change. Stemming.
Stemming.
Okay. So another concept here, or like another terminology here, is stemming. Okay. Stemming means bringing the word into the base word. As I said you, is that like a television, TV, and like this. Okay. Duradarsini, like this, all these words. Okay, bringing them into the root word. Okay. So this is like stemming, normalize words into its base form or root form. For example, it is given here like the words fish, fishes, and fishing all stem into fish. Okay, and results may not be the root word. For stemming, please you should remember that the results may not be the root word. Maybe like sometimes you have some example here like study, studies, and studying. Their stem is basically study, STUDI. That is the stem, which is not an English word basically. So stemming sometimes may not give you the root word. Okay, some of the common types of stemming algorithms are like Porter stemmer, Lancaster stemmer, and snowball stemmer. We'll see about this Porter stemmer and snowball stemmer. We'll see about this one. If possible, if I'm having this Lancaster stemmer, that one also we will try to deal it. Actually, more than this stemming, we use lemmatizer. Lemmatizer means see what the difference between stemming and lemmatization is. Like stemming algorithm do not give you it gives a root word, but that root word may not be a perfect word in English. Whereas lemmatizer, what it does is that it basically gives the root word. For example, good, better, best. Okay, good, better, best. For better and best, the base word or the root word is good, right? This we should get, that should be the base word. Now, like what is a lemmatizer? The slide got changed. Lemmatization.
No,
No,
sir.
sir.
No, sir.
So what is the lemmatization? Just to know that, like it groups together different inflected forms of a word, which is, we call it as lemma. Uh, it is similar to stemming, but as it maps several words into one common root word. So the output of lemmatization is basically a proper word. So as I said you that, for example, the lemmatizer should map gone, going, went into go. That should be the word here. So go, going, gone, went, everything. Like as I said you that a good, better, best, or better, best. It has to be mapped to go. The word go. This is what is called lemmatizer. Whereas if you take it a stemming algorithm, it will not give you. Okay. It will not give you, it will give you a root word, but that root word may not be the perfect word in English. Okay, this is what is the difference. Now, what is a stop word? So common words that are ignored by most search engines because including them actually increases the size of the index without improving any precision, recall, or accuracy, or any other parameters, F measure or as such.
It because we just now got the lemmatization slide. Yet to get the next slide.
Sir, I think problem occurs when you only showcase PowerPoint slide. If you share a whole desktop, then I think this lag won't occur.
Yeah, let me give you that then. Yes, that also may be because earlier never I faced this type of problems. Let me, yes. Is it okay now? See,
Yes,
I'm
sir.
changing it. Is it okay
Sir, now we are on stop words.
now?
Still on stop words.
Okay. So what is a stop word? You call this as the common words that are ignored by most search engines because including them basically increases the size, right? So that's why some of the words you try to ignore it, right? Maybe like some spaces, or maybe like a full stop, comma, punctuation, such type of things you may ignore. Okay, and did it get changed? Parts of
No,
No,
sir.
sir.
speech. What is this problem? I never had this problem earlier.
Yes, sir. Now it's changed. Yes, sir. Now it's
What's your
changing real time.
what's
Yes,
your
sir.
parts of speech? Okay, what is parts of speech tagging? So parts of speech tagging means, as I said you, that like every language has got its own parts of speech. Okay, there is noun, pronoun, verb, adjective, adverb, conjunction, preposition, article, and interjunction. This is with respect to English. Similarly, you have parts of speech in your own language. Okay, what I suggest you all is, please try to pull out the parts of speech in your particular vernacular language. Okay, so please make sure that you try to find out. Maybe like many people are English medium students, and many people, those who have studied your vernacular language, also you must have forgotten. But what I suggest you is, please, you keep up, or you try to know out, revise once the parts of speech. So in English, we are having the parts of speech, which is given on the top. Okay. If you see these 9 parts of speech, so given if, in the bottom, it is given here, right? A paragraph is given here. Hey, POS tagging simply means labeling words with their appropriate parts of speech. The parts of speech explains how a word is used in a sentence. There are 8 main parts of speech: noun, pronoun, adjective, verb, adverb, preposition, conjunction, and interjunction. If you see here, see like this is a complete sentence that is given. Okay, this is a complete sentence that is given, and this sentence, okay, for this sentence, what we need to do it, we need to tag, means assign a parts of speech for that particular tag. Suppose you see here, first one is hey, it's an interjection. Then parts of speech, you are stating something which is a noun. Tagging, it is the process, again action, so verb. Simply, okay, then you are trying to give that one as an adverb. Means, verb. Labeling, verb. So this is okay, or like adverb or something like that. You keep it like this, and completely, if you are able to tag each of the word, okay, each of the word with some parts of speech for a particular language, then you call this process as parts of speech tags. Okay, how are this, how do we tag this one? Initially, we need to have a data set which is already tagged. Okay, now you need to remember one thing, that these parts of speech tagging is like in English we say that like we are having 8, then like conjunction, interjunction and all everything, uh, or some 9 parts of speech tags that we are having in English now. But actually there are, with respect to tense, maybe like with respect to the number, with respect to the singularity, plurality, okay, uh, like this you have got, or we can classify them into different tags. Basically, two benchmark taggings are possible. One is the Penn tree bank tagging. Penn tree bank tagging is given by Pennsylvania State University, where we are having some 45 number of tags. And another one is a brown corpus tag. They are having some 86 tags, something around 86 tags, with a combination, with the different combinations. And mostly, so whenever you work it out in English, you have to use either Penn tree bank tagging or brown corpus tagging, Brown University tagging. Now, you see the tags and its corresponding descriptions are given here. CC means coordinating conjunction. CD is the cardinal number. DT is the determiner. EX is the existential quantifier or existential there. FW is a foreign word. IN is basically a conjunction, preposition or subordinating conjunction. JJ for adjective, JJR for comparative adjective, JJS for superlative adjective, LS for list item markers, MD for model, like that. NN for noun, or it may be a singular noun or mass noun, and NNS for plural noun, NNP for personal noun, proper noun, which is singular, and NNPS for proper noun, or maybe like plural also. PDT is a determiner, predeterminer, and a POS possessive ending. PRP is the personal pronoun. Like this, if you see on the right hand side also, there are some tags, right? There are so many tags that are available, and these tags are given by the Pennsylvania State University. Okay, Penn Tree Bank. That's why these are the standard benchmark tags generally which is used. For example, if a sentence is given, okay, if a sentence is given and you need to assign parts of speech tags for that particular sentence. Now, suppose a sentence is given as the waiter cleared the plates from the table. What is the sentence? The waiter cleared the plates from the table. So for that one, what is waiter? What is cleared? What is the? What is plates from the table? Like this, for each of these words, you need to assign with some of the parts of speech in a particular of that particular language. Okay. So in English, suppose when we say the is a determiner, waiter is a noun, cleared is a verb, the is a determiner. Like this, you have to assign. You have to assign each of the tags. Okay. Now, suppose it is given the dog ate the cat. The dog ate the cat. So the, you have to give it the is a determiner. Dog is a noun. Ate is a verb. The again is a determiner, and cat is a noun. So, but you need to understand, sometimes what happens is that in a sequential fashion, it is like we try to give it like sometimes the is a determiner, dog is a noun, but they dogged him. For example, if I give they dogged him, okay, they dogged him means they made him work like a dog, for example. So they dogged him means what do we mean by dogged here? It's an action. Okay, it is some performing some activity. So it is a verb basically. So it depends upon what is the previous word. So based on the previous word or previous sequences of words, then only you should be able to determine whether this particular word belongs to so and so parts of speech. So you need to understand, you cannot simply because you saw a word and commonly it is used for that parts of speech, but if you use some other context, in that context maybe the word meaning or the word parts of speech gets changed. That's why this is a sequential processing. Okay, this is a sequential processing, and sometimes you may have to use it, maybe like we use it in some sequential RNN, or maybe like we'll be using for parts of speech also. We can see that like a hidden Markov model and all this type of models, classical models, will try to we'll use it for this parts of speech tagging. Okay, so what is the need of parts of speech tagging? Basically, you can use it as a statistical NLP task, and you can distinguish the sense of a word basically. So what is the, so it depends upon what is the word, right? What is the word or where it is situated. So based on this, if you give the correct parts of speech, it means that the meaning, actual meaning, we try to get it. And sometimes what we mean to say is that the word sense disambiguated. Sense of the word is disambiguated. It means that the ambiguity is removed if you give parts of speech tagging. And it is easy to evaluate how many tags are correct basically. And you can also infer semantic information. Okay, this is all about the parts of speech tagging. Now I am into named entity recognition. So you give it like a sentence and you try to get a parts of speech, right? Like suppose I give it I am a boy. What is the parts of speech of I? What is the parts of speech of am? What is the parts of speech of a? And what is the parts of speech of boy? Right? You wanted to, you are interested in getting this. What is the parts of speech? So in your individual languages, also vernacular languages, you have got some parts of speech, as I said you, and you try to, can you tag it? And in India, there are so many languages, and we do not have parts of speech taggers basically for almost majority of the languages. Okay. Now, if somebody designs a parts of speech in your particular in your vernacular language, then definitely it's a new research. Of course, it must have not been developed till now. Okay, that is parts of speech tagging. Now you also need to find out what is the entity basically. Okay, we call that one as named entity recognition. I am into the new slide. Are you all? Named entity recognition.
Yes, sir.
Yes,
Okay,
sir.
so data extraction tasks are automatically finding and sorting into different categories like people, date, time, location, person, cardinal number, ordinal number, and organization. Like this, many things, many names may be there. So we need to remember that when somebody is giving, okay, something is given, like a sentence is given, what are the names or what are the entities basically? What are the entities and name them. Okay, that is like parts of speeching. We are tagging the each token or each word with respect to a particular parts of speech. But here in named entity recognition, we have to give, like if there are entities, if there are entities, then you have to name that entities. Okay, you have to name that entities with respect to particular named entity recognition. So if you have a set of NERs, named entity recognition tags, you have to assign that one. For example, I have changed the slide. NER example, is it there?
Yes, sir.
Yes, sir.
Okay, you see here given Steve Paul Jobs and some Wikipedia, from Wikipedia, if you see that Steve Paul Jobs and the pronunciation, and then it is given February 24, 1955 to October 5, 2011, was an American business magnate, industrial designer, entrepreneur, and investor. He was the chairman, chief executive officer, and co-founder of Apple Incorporation, the chairman and majority shareholder of Pixar, a member of the Walt Disney Company. Now you just see here in this sentence, okay, like complete paragraph it is given here. There are some entities. Steve Paul Jobs. So what is Steve Paul Jobs? It is a person. He is a person. February 24, 1955 to October 5, 2011. It's the date. American, NORP. Sometimes this one we refer as NORP to state that nationality or religious or political group. Okay, NORP, nationality or like a religious or political group, like that. Okay, we try to represent like that. Sometimes, like for example, like sometimes we give it like for buildings, airports, highways, bridges, etc. Also, or roads, like that we give it FAC or something, some name. Okay, it has to be provided with some name. Maybe like Apple Incorporation, it is an organization. Pixar is an organization. The Walt Disney Companies is an organization. NEXT is an organization. 1980s is a date. Apple is an organization. Steve Wozniak is a person. Okay. Uh, like San Francisco, geographical entity. California, it is a geographical entity. So like this, if you see in this particular, each sentence you need to, or each word you have to see whether it is mapping with any of the named entities. Okay, named entities. So what we need to do is that you have a complete sentence. How do we analyze this particular sentence? So first of all, we try to find out with the syntax, right? The syntax. So syntax is basically the study of rules that govern the way words are combined to form a sentence in a particular language. Is it visible now? What is syntax?
Yes.
Yes,
Yes,
sir.
Yes,
sir.
sir.
Okay. So these sentences are composed of discrete units combined by some rules. Okay. Now we need to find out for each of these words, we need to see, or that complete sentence is there, and it based on the rules and grammar of that language, we need to frame. Okay, we need to frame basically how the sentence is occurring, or what is the particular sentence, the syntax for that particular sentence. Now if you see a phrase structure, is it visible now? Phrase structure.
Yes, sir.
Yes.
Yes, sir.
Okay. Okay. So sentence represented as S. NP means, it means that sometimes you are referring two or three entities, maybe like two or three tokens combined together to make a phrase. If it is starting with noun, we call that one as a noun phrase. If it is starting with verb, we call that as a verb phrase. N is simply noun, V is verb. Okay, like that we have got different phrases, right? And these phrases, for example, a phrase structure, there may be a phrase structure. So conventionally, a phrase structure rules are usually of this following form. For example, in compiler you must have studied A produces B and C. For example, A produces B and C, right? It means that from A, okay, from A you are trying to produce something B and C. it means that when you combine B and C, you are going to get A. Okay. Example, you see in this, in NLP, you see here like S produces, okay, or S is, this sentence is framed by the start of the sentence, for example, is framed. The sentence comprise of noun phrase followed by a verb phrase, for example. Okay, this sentence is comprised of noun phrase followed by a verb phrase. So here in the below description, it is given as a S or a sentence consists of noun phrase followed by a verb phrase. Anything that is written in bracket, okay, it's an optional. Suppose you see in this diagram, if you see here, S comprises of noun phrase and verb phrase. It means that compulsory the noun phrase should occur, then it should be followed by a verb phrase. You see point number 2 here. Noun phrase is given as determiner followed by noun followed by pronoun followed by PN, personal noun, or something like that. So this sequence should be followed. It is given in bracket, so it is optional again. Okay, and if you, it can be like a verb phrase can be like this. A verb, after verb, what can happen? There can be a noun phrase, or after verb there can be a preposition phrase, or after verb there can be a adverb phrase, or it may be like this also. After verb there can be a noun phrase followed by preposition phrase, or after verb it can be a preposition phrase followed by a adverb phrase, or after noun there can be a noun phrase followed by a adverb phrase, or it may not occur anything except a verb. Verb phrase comprises of, it may comprise only of the verb also. If you see the fourth point here, preposition phrase may be given as the preposition followed by a noun phrase. Okay, a preposition followed by a noun phrase, and it is given here like AP. Okay, maybe like adverb phrase or adjective phrase, whatever may be. It may be a, maybe an adjective followed by a preposition or something like that. Okay, so this is the basic structure. So it is not like always it be in this, maybe. So example, it was an example. S produces, or S comprises of, S consists of noun phrase followed by a verb phrase. For this one, how it may occur, so how depth it may go, this, all this one are rules, right, for that particular language, rules of a particular language, right. Now if you see like earlier, what you used to watch in compiler design, that also gives like the same structure. Okay, S produces A and B. Okay, A produces something, B produces something. Okay, maybe like a B produces C and C produces some terminal. Okay, like this it may be there. That those are the production rules that you have seen in compiler design. So similarly here also you have got this type of rules. A sentence comprises of a, maybe like a given like a verb phrase, or like a verb phrase followed by a noun phrase, or a noun phrase followed by a verb phrase, or something like that. Any phrase it may occur. Phrasal structure. Okay, it may be there. So if you see this one in this particular slide, syntax tree, a tree representation of syntactic structure of sentences or string is given here. The old tree swayed in the wind. The old tree, if you see here, the old tree here, right, the old tree, the sentence is given here, the old tree swayed in the wind. So this is a sentence. This sentence is again categorized, or maybe like classified as noun phrase followed by a verb phrase, for example. And this noun phrase is categorized as, or tokenized, or divided as determiner, adjective, and noun combined together to make a noun phrase. So determiner is the old and noun is tree. Okay, verb phrase. If you see the verb phrase is you have the verb followed by a preposition phrase here. Preposition because it starts with a preposition word here. Okay, so this sentence comprises of consists of noun phrase followed by a verb phrase. Okay, and noun phrase again you are exaggerating with the production rules. Verb phrase again you are exaggerating with the production rules. Okay, you see this is a tree structure. Okay, this is a tree structure that is given. So what you need to do is that you may try to do with the chunking or chinking. What is the meaning of this chunking is like chunking basically means picking up individual pieces of information and grouping them into a bigger piece. Like earlier what we have seen, the tree, right? The old tree that you made it as a one chunk. Okay, you individual pieces you picked up and then you made a masterpiece or bigger piece. That is you call that one as a noun phrase. Now that is the same thing. So the bigger piece is known as the chunk. Okay, chunking. So in the context of natural language processing, chunking means grouping of words or tokens into chunks. Okay, this is what you call it as chunks. Earlier what we have seen, the chunking example is like for example, we saw the yellow dog. I changed the slide. Did you get it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
we saw
Chunking
the
example.
yes, we saw the yellow dog. We is taken as a noun phrase. So is basically a verb. Okay, the yellow dog combined together. This uh, yellow. Okay, the yellow dog. This is you should understand that yellow is adjective here. JJ is adjective. The determiner. The yellow dog. Dog. Something giving or qualifying this dog, right? Yellow dog. That's why this is the adjective. Okay, so the yellow dog. These combined together, you call this one as a noun phrase. Okay, noun phrase. This is a noun phrase. So this is called chunking. So the yellow dog, you are combining together this individual tokens you are combining together, or individual tags or tokens you are combining together to make a phrase. What is the that process is called as chunking. Another one is chinking. So this chinking basically helps us define what we want to execute from a chunk. There is a big chunk, but I wanted to execute only a small part of that chunk. So under chinking, we create a sequence of tokens which are not included in the chunk sometimes. So we try to segregate. We try to segregate from that chunk. Okay. Now I am into context-free grammars. I have just put the slide context-free grammar.
Yes, sir. It's
So
visible.
yes, so this context-free grammar in layman's term is a simple grammar where certain rules describe possible combinations of words and phrases. See, that is like productions simply. Okay. This is what we tell here. So context-free grammar basically is a tuple with 4 values that the n, which is a finite set of terminal symbols, the sigma or the alphabet set, finite set of terminal symbols again, and R is the set of production rules, and S is the start symbol. N, sigma, R, and S. So what you try to do using this one, so you generate a language L by capturing the consistency and ordering of these production rules, right? This is how we do it in a compiler class, right? A compiler using a compiler for a particular language, a computer language, right? This is how we try to do it. Now, for example, the context-free grammar example, if you see, S produces S consists of noun phrase followed by verb phrase. And noun phrase consists of determiner and which is nominal. Okay, nominal noun or something like that. Okay, with number also you are giving. So nominal produces noun, verb phrase produces verb, determiner may be a, noun may be flight, verb may be left. Okay, this is, so here also right side it is given here. S consists of noun phrase followed by a verb phrase. So if you see, this says that there are units called S sentence, NP noun phrase and verb phrase in this language, and that an S consists of a noun phrase followed by immediately by a verb phrase. And it doesn't say, you have to remember one thing, that it never says that this is the only kind of S. And it also never says that this is the only place where noun phrase and verb phrase occurs. So it can occur in any combination also. But when you say S comprises of noun phrase and without any bracket or something, it means that noun phrase should be followed by verb phrase. Okay. Uh, Next one is the concept of word embedding. So human languages is unreasonable effective at describing how we relate to the world. So with a few short words, we can convey even complicated ideas and actions with little ambiguity. Suppose you are chatting with somebody, okay, and you tell you ask that ASL. What does you mean? What do you mean ASL or HRU? You type it in WhatsApp HRU. How you? Okay, HU. What do you mean? How are you? Right? This is, but see, this is like for humans, this is very fine. How about a computer basically? Okay, how about a computer? On the other hand, if you see, the machines cannot understand natural language. Your codes are still line by line instructions telling the computer what to do and what not to do. So machine basically what not to do also is not given. That is very out of scope. That's why when you see unbounded, okay, you the or unbounded calculus, okay, you can say that like when you study a calculus language, okay, uh, uh, this tuple relational calculus or domain relational calculus and even database management system, you must have studied that relational languages, mathematical languages. Okay, if you must have studied there, so the expressive power of a query is something very different, right? The question that you ask, suppose you ask a query like, I want all the records which are not available in table T. What do you mean by this? It means that you want everything from this world, which is infinite. You cannot get it at all. Okay. So this is what you say, that like machines cannot understand basically the natural language, and we generally give what to do, we give it, but we also what it should not do, we do not give it, right? Like those are very less, because unless and until we draw a confinement for that one, then only it will function properly. Okay, otherwise it may go above and bound. So machines often miss subtle distinction in meaning the context. For example, you see here, a small example is given here. A bank will lend you money if you prove that you don't need it. What is the meaning here? What is the meaning? How will you explain this particular thing to a machine? A bank will lend you money if you prove that you don't need it. So, and it is given in a sarcastic way. Okay. Suppose somebody comes to your class and or your friend, you know that your friend and he is a very good, you know that he doesn't know martial arts. Okay. Or he does says that he comes and opens that I am planning to open a martial arts class, means martial arts coaching. Then immediately you say yes, 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 you should. Now, what is the meaning of this? Yes, 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 yes. 3 times, 4 times you told. Yes, yes, yes. You should.
Sir, you are not audible.
You are trying to give generally what is sarcasm? You use
Excuse me, sir, your voice is breaking. We're not able to hear you for the last few seconds.